Hello everybody, and welcome back to Programming Fundamentals Chapter 2 video lesson. Once again, I'm Professor James, and now we're going to be looking at Part 2 of this lesson, the fun stuff. Okay, so now we're going to be looking at how to read this code. Because in addition to knowing how to analyze a problem, devising an algorithm, which is the solution, where you write it in pseudocode or flowcharts using good old-fashioned English statements. You need to know how to not just write the code or translate it, you also need to know how to read it. Because there would be a likelihood that not only will you be coding, but you will be reviewing existing code so that you can maintain the program, so that you can update or upgrade the program. And in order to do that, you need to know what's going on with the program. So let's go ahead and do that. Now, one of the things that I do is what I call desk checking the program and tracing the values of the variables. So here I have two variables that have been declared, freeze and boil. So I am going to go ahead and key those in over here so that I can keep a table so I can trace their values throughout the execution. So initially they have a value of 32 and 212 respectively. Now the next statement here is freeze equals 0. That means instead of 32 being stored in the freeze variable, 0 is now stored in the freeze variable. And 100 is going to replace the 212 for boil. Now, the next statement is a display statement. That's the cout. We're going to display the value of freeze, which is 0. Press enter, the value of boil, which is 100. So this is what, and press enter. And this is what we will see in the actual program output if we ran this application. Now here's some things I want to talk about. Up here at the very top is what we call a preprocessor directive. Remember, it always starts with the pound symbol. The include is the command where we say, okay, I want to use the IOStream library so that I can display content on a screen, I can read information from the keyboard, and a few other things that you can do with cout and cin. And this is really important. This is what we call using the using statement. And what are we using? The namespace std. And std is short for standard. When we have these libraries, the libraries have tons and tons and tons of what we call functions and definitions for commands, and the list goes on and on and on. And because there's so many and they have like different reasons and purposes, they're placed into groups or categories. And so just in layman's terms, these categories are what we call namespaces. And so the namespace that we're using from IOStream is the std category, the standard category. If you explored IOStream library, you will find that they have additional namespaces that you can use. Now, why do you have the using namespace std? It's because if we didn't have this statement, I'm going to go ahead and comment it out so that it's not going to be recognizable in C++. Whenever we use the cout statement, we would have to precede it with std : Now imagine if you're displaying 40 lines of display statements. You would have to do the std : in front of every single cout. And so that can be pretty laborious after a while. Sometimes you may forget and leave one off, and then you'll get an error message as a result of that. So to avoid having to type std : each time we use the cout statement, we just include the using namespace std instead. So that's one of the main powers and purposes of having the using statement there. All right. Now, this is that, remember we talked about every program in C++ have to have a main function. This is how the main function is presented. You start with int, which is short for integer, that's the return type, followed by the name main, and a function has to end with open and close parentheses. Now, any blocks of code, like this block of code, must be enclosed in curly braces. And that's what we see here. Now, because this is an int main, once the program is done, we tell it to stop and terminate with this statement, return 0. And notice that each of these statements inside the curly braces ends with a semicolon. All right, let's come on up and take a look at this one. So we're including the IOStream library so that we can output. Now, in addition to IOStream, you may want to include other libraries that perform very specific tasks and have very specific purposes. And as you start learning more about C++ and how to solve problems using the language, you will find a lot of these libraries very useful. And you'll start looking at a few more of them when we get into Chapter 3. Alright, and if you notice, all of these start off with the include statement, which is the preprocessor directive, using namespace, int main, open and close curly braces, and return 0. Everything else is going to be different depending on the purpose of the program. Alright, so let's take a look at this one. So we have two variables, x and y. X has a value of 0, y has a value of 2. Now we're going to evaluate y times 4. We're going to replace y with 2. 2 times 4 is 8, and we're storing it in the x variable. And that's it. Notice that y has not changed, so y stays with the value of 2. Now that brings us to the cout statement, where we're going to display the value of x, which is 8. Press enter, that's what the indel says, and then display the value of y, which is 2, and press enter. And so the return 0 tells us the program is now terminated. Now here's where it gets fun. Okay, here we are displaying string literals, or so this is going to be really neat. So we're not maintaining any variables here, so I'm going to go ahead and get rid of that. Delete cells. Oops. Let's see, delete. I think it's in read only mode, so I'm not sure it's going to actually do it, but it did. Yay. Okay. Now here we're going to display I am the incredible, and you type it exactly as you see it. And notice that there's no spaces. So I am the incredible computing, and then we have the back. Once you see that backslash, that means you need to stop. And what are we going to stop? We're going to stop and press enter for new line. Machine. And then the next line, we're going to press enter again, because you see the backslash. And I will enter amaze, enter you, dot, enter. And gotta love Microsoft Office. It does this autocorrect. Yes, I could go in and change it, but then I have to change it every time. And there we go. So you're probably saying, how come there's no space in between incredible and computing? There is no space because we didn't tell it to insert a space. Notice here, after the double quote, there's no space after E. Before computing, there's no space before C. So therefore, it's all one word. The computer does exactly what we say and exactly what we display inside of the string literals. Alright, the next one is another output of our text. So if we go through this one, here's what's going to be fun. Once again, I'm going to get rid of these because we're not storing anything. So here we're going to say be careful. And then here it says we're going to stop and press enter. This might, oops, no spaces, be a trick question. Dot enter. You're probably saying, whoa, what has just happened here? Okay, we're going to type until we see a backslash. When we see a backslash, we have to stop and see what comes next. So here what comes next is the N. So that tells us we have to press enter. Then we say this might //n. We don't stop when we see a /. We only stop when we see a backslash. So that means we're going to type the / there. /n space be a trick space question dot enter. Yes, a backslash is not equal to a /. When it comes to programming, each character has a very specific value or purpose, and we cannot assume anything based on our vast amount of knowledge that goes on in our brain, because the brain of the computer is very limited. It only knows what we tell it. It only knows its language and its grammar. Okay, so / it will just be displayed. We never stop when we see one. We just keep on displaying or typing. All right, here's another beautiful monster. This one has a very interesting symbol that you're going to spend more time looking at in chapter 3, but it's my pleasure to introduce it to you now. So we have two variables, a and x, and at the time they have been declared, we have no idea what the value of a is. It's going to be some obscure junk value that the computer will give it, and then x is a value of 23. Now when we go to the next line, we have a equals x parentheses 2. The parentheses stands for modulus. This is modulus. And modulus is the remainder of division. Okay, remainder of division. So if you did good old-fashioned long division, for example, I'll go ahead and put it here. 23 divided by 2. You would end up with 11.5. That's what we would normally come up with, right? But what we really do, if you go back to elementary school, when you did long division, your teacher wanted you to share what the remainder is. Well, guess what? This is what a modulus returns. It returns the remainder. So now when you do a modulus operation, you're going to do long division. When you're all done, you can't go anywhere but bring down a 0. That's your remainder. And the remainder is the value of a modulus. So a is going to have the value of 1. And x doesn't change in that statement. So x has a value of 23. So what do we display? We display the value of x, which is 23. Press enter, the value of a, which is 1. And that is how the modulus works. Alright, this is so fun. I'm having a great time. Okay, fix the code. Oh my word, what is going on here? Okay, when we look at line 1, we have a // in the beginning and a /* at the end. They're heading in the right direction. It should not be */, it should be /*. So these two need to be flipped. I'm going to go ahead and just mark these with red so that you know that these are wrong. But this one should go over here, and these two should go over here to represent a comment line. Now let's look at line 2. What's going on with line 2? Yeah, I can't stand how this looks either. You're probably saying, please change it. So I'll go ahead and change it. Alright, now here we have the pound include. That looks okay. But the IO stream is missing something. What is it missing? It is missing the angle brackets that encloses the name of the library. For shame that we didn't do that. This is very common if you're typing really fast, you're just learning the language. It's very easy to make that mistake. And the using namespace, STD, that looks really good. So line 5, we have int main, open, close, parentheses. But there's something extra there that we don't need. And that is this baby, which is a semicolon. That should not be there. So I am going to just skedaddle this over here and put a comment on it because I'm going to let us know that it was there, but we don't need it. All right. Then we go to line 6. Yes, we need curly braces, but the first curly brace should be the open curly brace or the left. So it should not be this one. It should be this one first. So I'm going to switch these. And that looks so much better. Now we're going to go ahead and take a look at line 7. Line 7 is declaring 3 variables, A, B, and C. And it says 3 integers. But what something is really truly missing. And what's missing here is the semicolon. We need a semicolon here. We cannot forget it. Otherwise, the compiler is going to be very confused as to what it needs to do. Okay, we go to line 8. It's missing a semicolon, and so is line 9. Get out the way. And line 10. They all need semicolons. The assignment statements look good. The variables are on the left. The values, expressions, and variables are on the right. Now let's go ahead and take a look at line 11. Wow, line 11 has a lot going on too. First of all, cout must have a lowercase c. So I'm going to go ahead and do a comment around this so you can see what was originally there. And I'm going to color that in if it lets me. And then I'm going to go ahead and put the cout here. So this is what should have been there in the first place. Alright. And let's see, go on. Oh, it's missing another angle bracket. For shame. And let's go ahead and give it another color. And let's see, the value of C is, ooh, that's interesting. C is parentheses D. What is parentheses D here? Does that make any sense to us? Well, it does not. So the value of C is, I'm going to go ahead. This is a very interesting piece of code that we don't really use with cout. We use it for the old-fashioned C language, and it basically says we're going to display it as a decimal, but we don't even have the value of C in there to do that. So I'm going to go ahead. What I should have done was really just phase it out, but that should not be there. And then we need another angle bracket here. Let's go ahead and fix that. Now here we have a big uppercase C, right? But we have a lowercase c variable. C++ is case sensitive, meaning that lowercase letters are not the same as their corresponding uppercase letters. So uppercase C it will be a completely different variable name from lowercase c. So this needs to be changed to lowercase c. And it ends with a semicolon, which is good. We go to the next line. We return 0. And that's awesome. So now I'm going to go through this again just to make sure that the changes have been made. And if you guys see some things that I may have overlooked, do not hesitate to email me and let me know so that I can make those modifications too. Another thing that I want to do here is to add a space here so that is and the actual number doesn't mesh together. It's not very attractive. So now that we're done with that, it is time for us to go ahead and see what the output of this program will be. So we've declared 3 variables, A, B, and C. And A has a value of 3, B has a value of 4, and it caught me, didn't it? And C has a value of A plus B, which is 3 plus 4. That gives us 7. Now we're going to display the value of C is. So the value of C is, remember the space, and don't know why that's doing that. Oh, I know why that's doing that. Let me do a quick repair of what's going on here. Okay, is the value of C, which is 7. Voila. And that's it. And notice that we don't press enter because we don't press enter here. Okay, so this is what we're going to predict is going to occur if we ran the program. Well, guess what we're going to do? We are going to run this program. Yes. So now that you know how to go through and desk check and look at every character and every line of code, now we're going to see how the computer, the compiler, actually helps us do that. Okay, I have opened up my Visual C++. I'm using 2010 Express because it just loads much faster. The steps I'm going to take you through are pretty universal for 2010, 2012, 2013, 2015, whichever flavor you've decided to use for the class. So the first thing we have to do is create a new project. So you will search for new project and click on it. And it'll bring you to something similar to this. Now what you want to do is make sure that you have Visual C++ on the left hand side, and over here you want to look for Win32 console application. The order of yours may be slightly different, but you want to look for Win32 console application. Now the name for this one, I am going to go ahead and call it video lesson underscore ch2, so I know exactly which one it is, and click OK. And then from here you just click finish. Don't do anything else special. Now Visual Studio is amazing, but it has its own way of doing things, and so we're going to get a chance to take a look at what it does. Alright, now you're going to see some of the code here is different from what we have talked about. And here is how we work with the Visual C++ code. First thing I do is delete these 4 lines. The int main, int main goes away. You leave the stdafx.h. Don't touch it, pretend that it's not there, and keep it where it is. It should always be at the top above any code that you type. So here is what, I'm not going to do all of it, I'm just going to do the first part because it's really hard to type bad code when you have been working diligently to type really good code. But disregard my typos because That kind of happens sometimes. Okay, so I'm going to go ahead and just copy the code so that it's the authentically bad code that I'm working with. Alright, so here's the program. Okay, now here's where it gets fun. Alright, so notice that version 2010, if you notice down here, it's not going to give me any help. But yours should give you some squiggles. Okay, and if it doesn't, it's okay. But what I'm going to do is actually run this. Now up in the toolbar, you should have something that looks like this. It's a green play button. The purpose of the green play button is to build and compile your program and then run it if it is ready to run. So I'm going to go ahead and click on that button, and it says it's out of date. Do I want to build it? Say yes. And it should give me lots of bugs. Lots and lots of bugs. And it looks like I have so many that it doesn't even know where to start. There we go. It says there's some errors. Do you want to continue? Say no. So now you come down here to the output and you want to start looking at your errors. So I have a warning. It doesn't like this whole comment thingy. So I need to come in here and most definitely change that. So that should be /*. And notice that everything turns green. When I do that, that means that none of this will be seen by the compiler. And I'm going to end it with // and notice that everything now has its color coding. Now, just by fixing that, I should be able to see fewer errors. So I'm going to say yes, and it's going to say I have some errors. I'm going to say no, and look, I only have 2 this time. At first I had a lot. So it says, I'm having issues with your pound include. I'm expecting something. And so it says, oh, let me go ahead and put my angle brackets around it. That should solve that problem. So now I'm going to go ahead and run it again. And this is something I encourage you guys to do. You fix a problem, run it again to see what your other problems are. So by fixing the IO stream, it gives me another error. What I'm going to do this time, I'm going to double click on it, and it brings me directly to the error here. And it says, oh, it has an issue with that curly brace. So I'm going to go ahead and change that to the open curly brace. Let me go ahead and make this a little bigger for you guys so you can see this code much better. There we go. Alright. So it likes that much better. So I'm going to save a little time and change that one as well. And I want to walk you guys through so you can see all of this crazy code. And so now I'm going to run it again and see what happens. And some people will go through and fix and then run it. But as a beginner, I encourage you guys to do it one step at a time. So here, it's still having an issue with, it's saying it's missing the function header. It's like, where is my function header? Well, a function header does not have a semicolon at the end. So that's why I get rid of that. That's what this message means. It doesn't know. It's like, where's my function header? I need one in order to do anything. And so I always read that first error first. And usually by fixing that, it'll either fix everything or it gives me like a nice long list of other errors. And as we already noticed, we had a lot. So it says illegal escape sequence. Let's see, what is it talking about? Okay, you see we have these backslashes here. Oh, that's something that I did not catch. Let me bring in this one real quick. We forgot to catch that. And you guys didn't tell me either. This instead should be / with the space, because backslash, remember, it stops and waits to do something else. And there we go. And that's one of the things that I love about the compiler. Whatever we don't catch, the compiler will catch. So I'm going to go ahead and change that. And let's see if it takes that away. Remember, you can always double click on your error, read the message, and then fix what needs to be fixed. And here's what we know was going to happen. It's looking for that semicolon. It says missing one before identifier A, B, C. So we know we have to go ahead and put our semicolons in there. Yay! So you see what that error looks like. See, the bottom one didn't have one. And so it's saying it's missing. So we fixed all of those. And see, it says Cout undeclared identifier. Cout with uppercase C is not recognized as a command because it's not. The command is lowercase c. Oops, put in the wrong place. So that should be lowercase c. And let's see what happens because we don't have the angle brackets. Oh, did I forget a semicolon? Yeah, I did. There we go. So let's see what happens after we fix those issues. Alright, so we come over here. It doesn't know C. Remember I said lowercase c and uppercase c are two different entities. So I'm going to go ahead and take that off and make it lowercase c. And I love this. It's not looking at this as anything but a comparison. This is the less than symbol. See, it says unsafe use of type bool. Boolean returns true or false. It compares, two things, less than, greater than, equal to, or a combination of those. And so here it's looking at it as a comparison, which is not. So we fix those. And let's see, is it ready? All right. Uh-oh. Where's my program? Oh, I know what happened. It popped up and then disappeared. Here's why. We didn't tell it to wait so we can look at the display. So we have to do something to make it wait. So I am going to put cin.get. What this does is it makes the program wait before it terminates. And then we just press enter when we're ready for the program to terminate. So let's go ahead and give it a try. This should convert it to a decimal number, but I like to take mine out and just live with the numbers as is. Let's go ahead and see what happens. Alright, here it is. So the value of C is, and like I said, it didn't do anything. It's kind of redundant. I was hoping it would give us a decimal format like in the C language, but it doesn't. And so I'm going to take this puppy out, leave a space so that the value of C doesn't run into the word is. And let's go ahead and do this again. We love it when it doesn't give us any errors. And the value of C is 7. It's now a working program. And guys, I think I've covered a lot of the stuff that you are going to be exploring this week. And in chapter 2. And that's pretty much it. And, oh, when you're done, remember, just press enter. Voila, the program is gone. Without this line, it's just going to run, pop up, and then disappear because we didn't tell it to wait for us. Okay? Those of you guys who are running your programs in Mac using Xcode, Xcode is wonderful, but when it comes to output, you're not guaranteed to get the desired output. So I encourage you guys to take a look at using something like VirtualBox, using your using your DreamSpark account that we provided at Lone Star, and downloading Windows 7 or 8 or 10 and creating a VirtualBox for your Mac and install Visual Studio in it and use that so you can get the real output. Console output in Mac platform is very different from the console output of Windows. And so guys, I think that's it. I'm not going to torture you anymore. It was a great class, and I look forward to seeing you guys in the next video lesson. You guys have a wonderful week.